Hello, one and all present here. This is Amit Kumar Singh, and welcome to my class on work, energy, and power. One of the very important topic in physics, especially for class 10 students. So when I talk about physics, and in physics, whenever we talk about law of conservation of energy, we need to understand the relation between work, energy, and power. So probably whenever I say work and energy, so work and energy are more or less are correlated with each other, where probably the energy of a body is its capacity to do the work. While when I talk about work, work is a scalar quantity like energy, and work is said to be done whenever the body moves under the influence of force. So whenever we talk about work, so whenever I talk about work, so I whenever I talk about work, so work is basically it is a product of force into displacement, and this when we talk about force into displacement, so here the displacement what we are talking about, so this displacement what we are talking about, that should be a vector quantity. So basically, when you talk about work, so work is basically a force to the component of displacement. It is the component of displacement. It is a component of a displacement in the direction of force. In the direction of force. So here the direction matters a lot because although work and energy both are scalar quantity, but force and displacement they are vector quantity. So whenever you're talking about work, you need to understand the relation between force and displacement and the direction in which the body is also moving. That is also important to us. So in that context, I can define work as force into displacement. Suppose the symbol for force is F and the symbol of displacement is S into cos theta. So that is important for us to understand. So whenever we talk about work, the work is said to be done whenever the body moves. So you apply a force on the body and the body moves. So whenever the body is moving, probably in perpendicular to the application where the force is applied, then probably then the here the theta would be 90 degree, and then mathematically I can say the work is not done. Or probably the work is not done. Imagine if the body is not moving at all. Maybe you are applying energy on a wall. So maybe you are trying to push a wall, and gradually you can understand we are not a hitman or something. So that if you apply a force on the wall and the wall will get break or it get move or something like that. So the basic understanding is about work is that the work is equal to F into S into cos theta. So whenever I talk about work, the SI unit of work is joule, and the CGS unit of work is erg, where the relation between joule and erg is 1 joule is equal to 10 to the power 7 erg. Okay, now talking about energy, when I talk about energy, the energy is basically the capacity of the body to do the work. And whenever I talk about energy, I can discuss the relation between work and energy, where probably you can either talk about energy in the term of joule, or you can talk about energy in the term of calorie. So when I talk about calorie, 1 calorie is equal to 4.18 joule. And when I'm trying to understand calorie is basically it is the heat energy which is required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. So that way I can define a calorie, where 1 calorie is equal to 4.18 joule. Then you should know what is kilocalorie. So that is another way to understand the relationship. The other units of understanding energy, probably you can either whenever you talk about energy, you can talk about energy in the form of either you can use the unit called calorie, or you can use the unit called joule, or you can use the unit called watt hour, or you can use the unit called kilowatt hour. So these units of energy you can use depending upon problem to problem, where whenever I say 1 watt hour, whenever I say one watt hour, that is equal to 3600 joule. Fine. And when I say 1 kilowatt hour, when I say 1 kilowatt hour, that is equal to 3.6 into 10 to the power 6 joule. Okay. In subjects like nuclear fusion or fusion reaction, probably when I talk about radioactivity chapters like that, there's another unit of energy I can talk about, that is called as electron volt, where electron volt is the energy gained by the electron when it is accelerated toward a potential difference of 1 volt. So there you can remember the another unit, where 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So I believe that the charge of an electron, that is 1.6 into 10 to the power minus 19 coulomb. So these units and all, if you have basic understanding about them, so that would be really good for you. And then going further, if I talk about power, so what is basically power? So the power is basically the rate of doing work, that is called power. So power is, again, it is a scalar quantity. Work is a scalar quantity. Energy is a scalar quantity. Power is again a scalar quantity. And if I talk about power, so if I'm talking about power, so your power basically is basically, it is a work done divided by the time taken. So that is the basic definition about power. And here I can say work done. So work done, I can say, that work done is equal to force into displacement and divide by time taken. And that distance by time or displacement by time, that is equal to velocity. So other way, I can say power is equal to force into average speed. This is again another formula which you can keep in your mind. That is a relation between power, force, and speed. Fine. And the SI unit of power is watt, where I can say 1 watt is equal to 1 joule per second. So the SI unit of power is basically 1 watt. When I say the SI unit of power, so that is 1 watt, and that is equal to 1 joule per second. Fine. And then you know what is 1 kilowatt? That is 10 to the power 3 watt. Then you should know what is megawatt, and you should know what is gigawatt. So when I say megawatt, 1 megawatt is equal to 10 to the power 6 watt, and 1 gigawatt, that is equal to 10 to the power 9 watt. That you can keep in your mind. And then for mechanical engineering student, they use another terminology that is called horsepower. So where when I say 1 horsepower, that is equal to 746, that is equal to 746 watt, that is equal to 746 watt. So these are the basic understanding about the relation between different units on work, energy, and power. When I talk about force, what is basically force? So you remember that the Newton's second law of motion, that force is equal to mass into acceleration, and acceleration is the change in momentum. So rate of change in momentum. So probably I can say force is equal to force. When I define force, a force applied on a body is defined as the rate of change in the linear momentum of an object. And I can define force is equal to mass into acceleration, and force is a vector quantity. The unit of force you can use is a Newton or dyne. Newton is the SI unit, while dyne would be the CGS unit, where one Newton is equal to 10 to the power 5 dyne. So the other unit of force you can either use whenever you talk about force. You can for the force, the force is a vector quantity. So for the SI unit, many people use Newton, and you can use also you can also use kgf. So here when I say 1 kgf, so 1 kgf is equal to it is basically g newton. So basically g stand for acceleration due to gravity. So depending upon problem, in some problem g is given as 9.8 meter per second square, or in some problem it would be given as 10 meter per second square. So you can see, if nothing is given, you can take 9.8. Otherwise, if they want you to take 10, they would mention in the problem. So let me first clear the objective of this class. So for me, my target students for whom I'm developing this video is those students who are preparing for physics in their class 10th standard of ICSE. So probably CBSE students can also go through this video. Those who are in class 11th standard, so they can also have this chapter called Work, Energy, and Power. But for 11th standard students, the questions what I'm going to discuss will be comparatively easy. Again, all the students who are preparing for some form of competitive exam, where physics portion used to come, more or less in many government exams, the physics portions used to come, and the questions on physics used to come. So for those people, what all I have discussed till now, the units and all, this will be important for them. So that's why in the beginning only I discussed these units, conventions and all, that will be important for them. So it depends what you are expecting from the session. So that way it will definitely will serve your objective. In this class, I will not focus more on theory part. I'll try to do numericals uh, for 10th standard ICSE students. So for them, those who are preparing for 10th standard, that for them this would be direct relationship, and that way it will definitely will help them for the class. So one by one, I'll do numericals based on this chapter called Work, Energy, and Power, and this is my session number 1. Okay, so let me take the numerical. So let me take the numerical. Anyway, so let me take the first numerical. So this is your first numerical. So you can see a body when acted upon a force of 10 kgf. So here the force is given as 10 kgf, get displayed by 0.5 meter. Uh, Calculate the work done by the force when the displacement is in the direction of force. So whenever the displacement is in the this point 1, so whenever the displacement is in the direction of force, then you can understand in that case the theta would be 0. So theta would be 0. So if theta is 0, if theta is 0, those cases, if your theta is 0, then you know the formula, work is equal to F into S cos theta, and if your theta is 0, so then cos 0 degree is equal to 1. So the work would be equal to F into S. So here the force is given to you 10 kgf, and G is given as 10 Newton. So G is given to you as 10 Newton. So probably as I already mentioned to you that when you say force, here the force is equal to 10 kgf. So I can convert because if I want the values in the work in the form of joule, then the force should be Newton. So I'll convert 10 kgf into Newton, and you know that 1 kgf is equal to 9.8 Newton. If G is acceleration due to gravity is 9.8 meter per second square. Here G is given 10 meter per second square. So I can directly here I can use G value as 10. So probably the force here would be 100 Newton. So in this case, the force for you would be 100 Newton. So your force is 100 Newton, and the displacement is 0.5 meter. So I can say the work done is equal to 50 joule. Okay, then the next thing is that at an angle of 60 degree with the force. So if this is the first part, so if the second part is the angle of 60 degree with the force, so when I'm saying angle of 60 degree with the force, so here the direction matters. because it is a displacement. Displacement is a vector quantity. So the force is your 100 Newton, and S is zero point 0.5 meter, and cos 60 degree is 1 by 2. So then you will get the answer called 25 joule. Fine. Because already you found F into S is 50. So half of 50 is 25 joule. And then the next part of the question is normal to the force. So if as I already mentioned to you that the work done will not be considered in the language of physics if the application of force, the direction where you apply the force, and the displacement, the way the what is the direction in which the body moved, if they are perpendicular to each other, then the theta will become 90 degree, and cos 90 degree is 0. So whenever the force is applied, normal is 90 degree perpendicular. So whenever the force is applied 90 degree or in the direction of displacement, in that case the work done will be 0. So work done is equal to F into cos 90 degree. So here whenever you say cos 90 degree, that is 0. Work done will be 0. Fine. So this is the numerical one. I hope you would have understood this very easy problem. Fine. So we'll do then second problem. Let me first take the question. So one by one, I'm just taking questions. So this is the second problem. So you can see this is the second problem. So a body of mass 40 kg climbs up the stairs and reaches the roof at a height of 8 meter in 5 seconds. So calculate the force of gravity acting on the body. Whenever you say the force of gravity, that it is m into g. Here the mass is 40 kg and g is not given. So U is given, take g is 10. So this would be 400 Newton. Okay. Then work done by him against the force of gravity. So work, if he's trying to climb the stair, so he's working against the gravity. So if he's working against the gravity, so then work done by him would be m into g into h. So he's converting his kinetic energy into potential energy. So m into g is all is 400 Newton, and he climbed a height of 8 meter. This would be 3200 joule. Fine. This value would be 3200 joule. Then the third thing is the power spent by the body. So when you talk about power, power is basically when I talk about power, power is basically work done by time taken, and the time taken should be in second. So here when you say power, when I say power, power is equal to work done. Power is equal to work done by time taken. So power is equal to work done by time taken. So here the work done is 3200 joule and the time taken is 5 seconds. So you can divide it by 5. So the best way to divide it by 5, either you can divide it by 5 or you write 10 by 2. So this way you can say 640 watt. So the power would be 640 watt. The unit of power is watt. So that way we get it very easy problem. I don't think anyone will have a doubt on this. So you can go through, you can pause the video whenever you feel there's a difficulty in understanding, and then gradually you solve it and then check your answer based on that. Okay, so I hope you understood this. Let me do the next problem. So this is question number third. So a man spends 6.4 kilojoule of energy in displacing a body by 64 meter in the direction in which he applies force in 2.5 seconds. Calculate the force applied. So here the work done uh, is, is 6.4 kilojoule. So 6.4 kilojoule I can write as 6400 joule. This is the work done, and the displacement here, the displacement is 64 meter, and then time is given to you is 2.5 second. Okay, so what they're asking you the force. So you know the formula that work is equal to F into S cos theta. And here the direction is same as the where you're applying the force. So theta is 0. So work done is 6400. Force you want to determine, and this and the displacement is 64 meter. So I can determine my force. My force is equal to 100 Newton. Okay, then the power spent by the men. So that they're asking in horsepower. So the what is power? Power is nothing but, whenever I say power, power is nothing but work done by time taken. Work done is 6400 and time taken is 2.5 second. So 2.5 second I can write as 5 by 2. So this I can write to 5 by 2 I can write as, I can write this as 10 by 5, I can write as 10 by 2. So 10, 10 get cancelled. So this I'll get as 640 into 4. So this is 0, 16. This is 2560 watt. I got the answer as 2560 watt, but they want the answer in horsepower. So you know that 1 horsepower is equal to 746 watt. So 2560 watt is equal to how many horsepower? So the power in horsepower will be equal to 2560 divided by 746. So this would be 11280 divided by 373. So this is 1280 divided by 373. So 373 threesa will be 9, fourza will be 11 something. So 373 fourza, if I do 12, 29 to carry 14 points. So this should be threesa. So 373 threesa if I do. So 373 threesa, 373 threesa, 921 1119. This would be 11119. This is 1, this is 6, this is 1. So this is 1610. So 373 fourza. So 373 fourza, 373 fourza 12, 1 carry 29, 2 carry 1492. So this I can take fourza. So this would be 1492. This would be 8, 10, 9, 1, 1. So this is 1180. So 1119. So 1119. So this would be around 3 only. So I can say the answer in horsepower, that would be around something related to that would be 3.43 horsepower. So this would be answer, approximate answer, not the exact answer. So I hope you understood this. Easy problem. Now we'll solve this question number 4. A weightlifter lifted a load of 200 kgf. So you can, here G is 10. So I can write this as 2000 Newton. I think by this time you are comfortable with this. And the height of you raised is 2.5 meter. And the time is 5 seconds. The time is 5 seconds. Calculate the work done. So the work done, the formula of work done is force into displacement. So here the work done will be 2000 into 2.5. So this I can write as 2000 into 5 by 2. So this I can say that is work done is equal to 5000 joule, and then power developed by them. So power is equal to work done, that is 5000 divided by time is 5 seconds. So the power is 1000 watt or 1 kilowatt. Fine. So now we'll do question number 5. A machine raises a load of 750 Newton. A machine raises a load of 750 Newton through the height of 16 meter in 5 seconds. Calculate the energy spent by the machine. So calculate the energy spent. Energy means work and energy both mean same thing. So the energy or work is force into displacement, that is 750 into 16. So I just multiply this. 16 into 75. 16 5 is 80. 16 7 is 112. This is 1200. This is 12000. So that is the joule, 1 to 12,000 joule. And then power of machine if it's 100% efficient. So the work done is 12,000, and work done divided by time, that is your power. You know this, work done divided by time, that is your power. So work done is 12,000 and the time is 5 seconds. So I can write this at 10 by 2. So if I write 10 by 2, then 1200 into 2, that would be 2400 watt. So the next question, an electric heater of power of 3 kilowatt. So power 3 kilowatt, I can write as 3000 watt. Okay, and used for 10 hours. So the 10 hour here, when we do conversion, the time should be in second. So here the time is 10 hour. Okay, so keep that in your mind whenever you do time joule conversion. Other thing, remember the unit of time should be in second. How much energy does it consume? So how much energy does it consume? So you know that power formula, power is work done by time taken. So work done or energy both mean same thing. So that is equal to power into time. So work done or energy both are equivalent. So power is 3000 watt and the time is 10 hour, and this you should convert into second, that should be equal to 3600 second. That should be equal to 3600 second. So this will be equal to, so this is equal to 108. Then how many zero? 1 2 3 4 5 6 into 10 to the power 6 joule. So the energy here would be, I can write that is 1.08 into 10 to the power 8 joule. Okay, then how much energy does it consume? So so express your answer in kilowatt hour. Acha, if I want the answer in kilowatt hour, and so if I want, you should know 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Okay, so if I want the answer in kilowatt hour, so this would be equal to 1.08 into 10 to the power 8 divided by 3.6 into 10 to the power 6. This will be equal to 108. This will be equal to 1.1. So this I can write as 108 into 10 to the power 6. That get cancelled. This is 0. So this is this is 180. 36 threes are 30, no, 36 threes are, this is 18, 9 9 10. So this would be equal to 30. So this will be equal to 30 kilowatt hour. Other way, if you directly would have done here, 3 kilowatt for 10 hour. So this would be, so kilowatt hour. So kilowatt is 3 and hour is 10. That would be 30 kilowatt hour. Directly you could have done there. Now, question number 7. Now, if you see question number 7, a water pump raises 50 liter of water through the height of 25 meter in 5 seconds. Calculate the power of the pump required. So here the density of water is 1000 kg per meter cube. So if I talk about density of water, if I talk about density of water, that is 1000 kg per meter cube. And you know that 1 meter cube is equal to 1000 liter. And I believe you are aware about this thing. So, so 50 liter is equal to 50 by 1000 meter cube. Now you know that the density of water. So now you know that density. Now we know that. Now we know that the density of water is equal to 1000 kg per meter cube. That means 1 meter cube weight of that, sorry, mass of that is 1000 kg. Here the water is, here you water is 50 into 50 divided by 10,000 meter cube. So your water is 50 divided by 10,000 meter cube, or I can write 5 by 100 meter cube will be equal to how much kg? That would be 5 by 100 into 1000. I can say 50 kg. So that is the mass of water, 50 kg. So here in this question, the mass of water is 50 kg. So the m is equal to 50 kg. Okay, and the height is 25 meter. Okay, and the time is 5 seconds. Now I can easily calculate the power. So I know the formula of power. Power is work done by time taken. Work done is mgh, and the time is t. So this is 50. G is given to you. Take G as 10. So you take G as 10. Height is 25 meter, and the time is given as 5 seconds. This you can write. So this would be equal to 2500 watt. Okay. I hope you understood this. Then we'll do question number 8. Now see question number 8. So weight, mass of what is given 500 kg, depth is 80 meter, time is 10 seconds. What is work done? Work done would be 500 into 80, m into g into h. G is they are taking 10, so m into g into h. So this will be equal to the work done by pump. This is 40. Then how many zero? 1, 2, 3, 4. 4 0. So work done by the pump. So so you can say this is a work done by pump, that is 4 lakh joule. That is a work done by the pump. So that is 40. So 1 2 3 4. Then 1 0 is already there. No? 1 2 3 4 5. Total 5 zeros is there. 4 into 10 to the power 5 joule. Then when I say what is the power at which the pump works, so what is the power? The power is work done by time taken. So your work done is 4 into 10 to the power 5 joule, and that time is given to you 10 seconds. So you can find the power. Power will be equal to 4 into 10 to the power 4 watt, or I can say power is equal to 40 kilowatt. And because you know that 1 kilowatt is equal to 10 to the power 10 to the power 3 watts. Okay, then they're asking you what is the power rating if its efficiency is 40%. So you understand, if the efficiency of pump no, they're asking if the efficiency of pump if the efficiency of pump is 40%, its power is 40 kilowatt. Power is 40 kilowatt. Now they're asking you power rating, means when its efficiency is 100%. So they're asking you power rating. So that means they're expecting you to calculate what would be the power if the efficiency of the pump is 100%. So then its power will be then its power will be at 40%. It is generating a power of 40 kilowatt. At 100%, it will generate a power of 100 kilowatt. Simple. Fine. Then next problem. So your next problem, an ox can apply a maximum force of 1000 Newton. It is taking part in cart race and able to pull the cart at the constant speed of 30 meter per second. So power formula, you know that force into average speed is power. This is 1000 and the speed is 30 meter per second. So the power would be 30 kilowatt. This would be a power. Already I discussed this formula with you, so you know that. Then then you can see question number. You can see the question number 10. You can see the question number 10. Power is 40 kilowatt, and the speed show that the force is 20,000 Newton. So you can do it very easily. So you know the formula, that power is equal to force into velocity. Power is equal to force into velocity. Power is given 40,000, 40,000 watt, and the force is 20,000. So the speed would be 2 meter per second. You can easily find 40,000 divided by 20,000. That would be 2 meter per second. So there's no need for me to do this problem. I hope you understood. Question number 11. Razan exert a force of 150 Newton in pulling the cart at the constant speed of 10 meter per second. What is the power exerted? So you know the formula, that power. You know that formula, that uh, you know the formula here, that power is equal to, you know that power is equal to force into speed. You know that power is equal to force into speed. So here the force is 150 and speed is 10 meter per second. So the power would be 1500 watt. Simple. Simple. You know the formula. Power is equal to force into Newton. Force is 150, speed is 10. The power would be 1500 watt. Then question number 12. Question number 12. A boy weighing 350 Newton climbs up to 30 steps, each 20 centimeter high in 1 minute. Calculate the work done. So work done, what would be the work done? So force is 350 and the distance is 30 into 20, and that is 20, 30 into 20, that is in centimeter. So convert that in meter, because you know that for the joule is Newton meter. So here in question number 12, if you want to do question number 12, if you want to do question number 12, so in question number 12, the force is 350 Newton. The force is 350 Newton. The force is 350 Newton and 30 step, 20 centimeter high. 30 step, 30 step, 20 centimeter high, 20 centimeter high. So the work done will be 350 into 30 into 20. Convert that into meter, because the distance should be meter. So this is m into h, and the g value should be given to you, and the g is not given anything. So calculate the work done. So I'll take what value of g. Should I take 10 or 9.8? But that is not given. So let's take 9.8 because it is not given. So this would be 0, 0, 0, 0. This and this 0, this 9, this I can write as 90, this 98 by 10. All 0 will get cancelled. So work done would be 35 into 3 into 2 into 98. So this would be the work done. So work done would be, this is 115, this is 105, 35 5 3 is 105 into 6 into 98. This is 30, and this 6 5s are 30. 6 5s are 30. This is 630 into 98. So, this should be, if I take 100, then this should be 65,000, 63,000 joule, or around 63 kilojoule, 63 kilojoule. So approximately that would be your answer. Approximately 30 step is 20 meter high in 1 minute. Find the work done and the power spent. This is given to 100, 350 mg. So force is 350. Okay, okay, that is given. No, okay, okay, sorry. That force is given to you. Then no need to multiply with g. No, okay. Force mass is not given. Force is given to you. Okay. So here I did not notice. Here they given you the force. So here the force is given 30 centimeter, 30 steps and 20 centimeter high. This is 20 centimeter high. So you know the formula of work done. Work done is force into displacement. Force is 350 and this is 30 into 20 centimeter. Convert that into 100. This 0, this 0, this 0, this 0 will cancel. This is 350 into 3 into 2, 6. This is 0, 0. This is 18, 2100 joule. Because the force is given, so that is m into g was given to you. Then no need to consider the g value and all. Okay, then they're asking you the power, and the time is given to you 1 minute. So they're asking you power. So power is work done by time. This is 2100, and the time is given as 1 minute. So convert that into second. So this convert that into second. So that is around 35 watt. This is equal to 35 watt. Then you can see question number 13. It takes 20 seconds. See question number 13. It takes 20 seconds for the person of mass 50 kg to climb up the stairs while another person of same mass does it in 15 seconds. Compare the work done. So whenever you say work done, so here whenever you're comparing the work done, the formula of work done is m into g. The both the mass is same, g is same for everything. This is h1 by mg h2. So the height, so mass 50 kg climb up the stair, another person. Okay, the height is also same here. So everything is same. So everything is same in both the case. So what is the ratio of the work done? That would be 1:1. And compare the power. So when you say power, P1 by P2, so that power is work done by time taken. So this is work done by time taken. So you can write this as work done into time taken by second person divided by second work done by T1. So both the work done is, you know that both the work done is same. So this is T2 by T1. So first one is doing 20, other one is doing 15. So the ratio will be equal to 3:4. Very simple problem. Now see question number 14. A boy weighing 40 kgf. So the force here would be 400 Newton. Uh, uh, Climb up the stairs of 30 steps. 30 step stairs. Okay, each 20 centimeter high. Each 20 centimeter high. Time is 4 minutes. Okay, so and the girl weighing 30 kgf. This is the boy weight. This is the force exerted by girl, that is 300 Newton. So assuming G equal to, here I'm assuming G is equal to 10 meter per second square. So does the same, again the same data, does the same in 3 minutes. So here what is the work done by them? Compare the work done by them. So work done by them, W1 by W2. So that is force of boy into distance, both are covering the same distance. Okay, so divide by the force exerted by girl, that is, so here this is 400, that is h, this is 300, that is h. So the ratio of the work done is 4:3. The ratio of the work done is 4:3. And then time is given to you. So now you know the ratio of work done, that is 4:3. So now, now time is given to you. They're asking you the ratio of power. So you know that power P1 by P2. So that is nothing but work done by first into time of second, and work done of second into time of second. So this is P1 by P2. This is given to you. This is 400. So this is the ratio of their work done is given to you. That is 4:3. So that is 4:3, while the time of second one is 3 minutes, and the time of first one is 4 minutes. So you can find, so the ratio of the power will be 1:1. Now see the next question. Question number 15. A man raises a box of mass 50 kg to the height of 2 meter in 20 seconds, while another man raises the same box to the height in 50 seconds. Compare the work done. So another men, the mass is not given. Assuming both the men same mass, m1 equal to m2. Okay, and both person G will be same. You know that G is same and same height. So same height where H1 is equal to H2. So then work done of first one will be equal to the work done of second one because work done formula is MGH. So M is and the other person mass is not given. So I'm assuming that to be same. So then MGH for both the person would be the same value. So the work done. So the compare the work done. So that would be 1:1. Then they're asking you the ratio, power ratio. So if I'm asking P1 by P2, so work done is same. So that would be in the ratio of T2 by T1 because the work done is same. So you can understand power is work done by time taken. So the first one, the second one is 50 second and the first one is 20 second. So the P1 is to P2 will be 5:2. We calculate the work done and power developed by each man. So what is the work done by the first man? So if I say the work done by the first man, so the work done 50 into mg. G is 10, H is 2 meter, H is 2 meter. So mgh. So work done. So the work done just so this you can this is 100, this is 1000 joule. This is the work done and the power developed by each man. So the power both are doing same work done. So power of first man that is 1000 divided by 20. 1000 divided by 20 that is 5 watt and the power of second man that would be 1000 divided by 50 that would be equal to 1000 divided by 50 that would be equal to 2 watt. Okay, this is 2 0. 5 watt and 2 watt. So 50, 50, 1000 joule 1 minute. So this is 1000. So time is 20 seconds. So 1000 joule. So power is work done by time taken. So this is 50, no? 100 divided by 2. This is 50. 100 divided by 2. This is 50. This is 100 divided by 5. This would be 20. And zero calculation. Okay. Then you can see the next question. Then this will be the last class of, sorry, this will be the last question of this class. So by that I'll finish the first exercise. A boy take 3 minutes to lift. A boy take 3 minutes to lift 20-liter water bucket from a 20-meter deep well, while his father does it in 2 minutes. So compare the work done. So again, the mass is not given. So mass you can find that. So here the density of water all. So you know that 1 meter cube is equal to 1 meter cube is equal to 1000 liter. So 20 liter equal to 20 by 1000 meter cube. So 20 by 1000 meter cube. So 20 liters 20 by 1000 meter cube. Uh, you know that 1 meter cube is equal to 1000 kg. So 20 by 1000 meter cube will be equal to 20 kg. Okay. So a boy takes 3 minutes to lift 20 liter water bucket from 20-meter deep well, while father does it in 2 minutes. Compare the work done. So here when you see work done is M into G into H. So both are covering the same distance. Here the value, here the both are lifting the water, and the mass of water, same water, that is also constant. So the work done will be 1:1. The work done will be 1:1. Then power developed by them. So here work done is same. So the power ratio, that would be T2 by T1. So the T2 is 2 minute, and minute you can convert into second. And so minute, second, second, that get cancelled. This is 3. So P1 is to P2 will be equal to 2:3. Then how much work each does. So both are doing the same work. So the work here, if you see the work, so the work mass you got is 20 kg. So your mass you got is 20 kg, and the G you take 9.8 mgh. H is 20 meter. So the work done would be equal to 400 to 9.8. So your work done will be 40 into 98. So your work done will be equal to 0. This is 32, 3 carry. 8 fours are 32, 8 fours are 32, 3 carry. 3920 joule. So that would be the work done. 3920 joule, or you can write 3.92 kilojoule. So this would be the last question. This was the last question. So I hope you have understood here. So the numericals, what all we did were easy numericals. So these all were based on formula. And if you understood the concept of work, energy, and power, for you to solve the problem will not be anything difficult. Basic unit conversions, another thing you need to remember, that 1 joule is equal to Newton into meter. 1 Newton is equal to 10 to the power 5 dyne. 1 joule is equal to 10 to the power 7 erg. Fine. Joule is equal to joule, and calorie, when I say 1 calorie is equal to 4.18 joule. Okay, 1 calorie is 10 to the power 3 joule. Then then kilowatt hour is equal to 3.6 into 10 to the power 6 joule, and 1 electron volt is 1.6 into 10 to the power minus 19 joule. So basic conversions, power is equal to work done by time. The time should be in second. And then in work done formula, the distance should be meter. The force should be Newton. 1 kgf is equal to 10 Newton if G is equal to 10 meter per second square. Otherwise, 1 kgf is equal to 9.8 and Newton if G, acceleration due to gravity, is 9.8 meter per second square. So basic unit conversion, if you are good with that, so for you solving the problem, what all I have done will be very easy for you. So I hope you enjoyed my class. So with that intention, I like to say goodbye to all of you. Thank you everyone. Bye.